We're completing 15.1 and we're looking at Boolean algebra postulates. Boolean algebra can be used to solve complex expressions in order to simplify a logic circuit. Most modern designs and nearly all complex logic circuits are internal to ICs. Boolean algebra has a number of basic rules called postulates or identities and should be studied closely to understand their functions and applications. 36 of these are listed at the end of section 15-1. They are listed for reference purposes. Your text doesn't go into detail about them, but we will be referring to them as we go through this chapter. And Boolean algebra postulates. To reduce a Boolean expression, and we're going to be doing this. We will be reducing a Boolean expression, and this procedure is helpful. Count the number of vincula above each variable and above each operator. Now these are the not symbols. Variables with an odd number of vincula have a single vinculum in the final expression. Operators with an even number remain as they are, whereas operators with an odd number will change. Okay, as we're going to do some examples of these, and we'll try to make a little more sense of this statement. Use parentheses where necessary to ensure that all variables that were grouped in the initial expression remain grouped after the simplification process. And so your textbook has 6 examples at the end of this chapter. I'm going to go through each of these 6 and give a little more detail. In fact, I'll give a lot more detail than your book gives on these expressions. Okay, the first one looks like this: A or B or C or D. And then we have 2 not signs. Now, if we were going to build a circuit based on that expression, it would look like the expression right here. We would have a NOR gate. Notice the NOR, because we have the entire equation is OR, but then it is completely knotted, so that would indicate a NOR expression. And then the D here, input D, is also inverted, so I'd have an additional inverter right here. Now, the purpose of Boolean reduction is to simplify this expression. And so what we would do, we would come in and we would break all of the not symbols in order to separate each variable and each operator. So what we're going to do is we're going to we'll split it here, and we'll split it here, and we'll split it here. Or we should say, maybe a better word is break it. So we'll break the vinculi in these 3 places. So in doing this, some things will happen to the equation. Now, when I break a single line, it's going to change the operator. It was OR, now it will become AND. Now, when it's a single, you change it. If it's double, if it's even, it remains the same. And we also were breaking this so that our knots now, instead of having a knot over the entire equation, we would just have a knot like this right here. So, and this is equivalent to that. Then we'll come to the next one, and we will do the same with it. We'll break it, and we'll change the operator, and this will become C naught, and then this one also, and this one will become, now this one, notice there are 2 not symbols here. Now each of these is an inverter, so if you invert something twice, it's back to the original sign. So what we could do is we could just cancel this, and then this has no inversion symbol over it. And so this is the Boolean simplification of this expression. And so we could do something like this if we had our 4 inputs, A, B, C, and D, and if we had an inverter here, an inverter here, an inverter here, and then we had our final output here. This would be the simplified version of this particular expression. Okay, we'll go to the next one. And here we have a little bit more complexity here. And this is the circuit. We'll note let's just look at the basis here. Let's see, we have A or B, and it is knotted. So this would be this expression right here, A or B, and then we have the not symbol over it. Then here we have C or D, and it is knotted, so that would be this expression right here. And then they are combined with the and expression right here, and then the entire expression is knotted, so that would be this right here. So this would be the circuit expression for this. So let's go in and simplify this. So again, we will break it here, here, and here. And so let's see, here we've got double lines, so that's going to, so the final expression will be, we'll have an A and a B, but there will be no inversion because they cancel. And we will keep this, the parentheses, because if they're grouped in the original expression, you need to group them in the expression that follows. But this will remain an OR because there are an even number of vinculi, so they would remain the same. Okay, here we would here we have an AND. Now this would become an OR, and in this expression we would have C plus D, and let's see, we have the operator remains the same, and we cancel that, and so we have something that looks kind of like this. Now if we looked at the those rules, we would see that this expression actually would simplify to A plus B plus C plus D. And so we could, 1, 2, 3, 4, A, B, C, D. This expression would simplify to this. Now this one actually we do see it is quite a bit simpler. Some of these you look at them and you think, well, they didn't simplify very much, but this one in fact does simplify significantly. Okay, third one. Okay, and here we have okay, A plus BC plus D, or A or BC or D. And so we would break it here and here and here. And so let's see, this one would be A, and this one would be let's see, we'd have B or C, and we need to keep the bracket, and this would be and D. Now given this expression A and D are both inputs here, we could, since these are both ANDing, we could say, oh, excuse me, we need to do something here before we continue. We need to make sure that we retain the knots here. Okay, this would be a B knot, and this would be a C knot, and this would be a D knot, and then the A would be the only one that's not knotted. Okay, so now we'll continue. We could say, we could combine these two, A D knot times B knot plus C knot. And we could, some would just leave it like this. We could go a little further. We could multiply this times these two, so that would give us A D knot B knot plus A D knot C knot. And that would simplify to, let's see, we would have two AND gates, and they would feed into an OR gate, kind of like this. And there'd be three inputs here, and that'd be basically our simplification. I hadn't included all the knots, but you get the idea. Here's an AND, here's an AND, and this would be an OR. Okay, this is number 4 here, and this is our circuit, and we're going to split it here and here, and we are, let's see, this would be A naught plus B naught, and then that would be ANDed with C. And now let's take a look at this. Let's make sure we've got this right, A and B. So this would be A naught plus B naught, and then this would be ANDed, and that would be a C. And let's see, what can we do with this? We've got, okay, this would be, actually we would have a grouping here because these are together. And so if we wanted to simplify this further, we could say we take this, ANDed with this, so we could end up with A naught C plus B naught C. And that would simplify to 2 AND gates ORed together. And let's see, if we had a, let's go ahead and then we had a, let's put B here and let's put C here. C is going to actually be common to both, and the B would be here, the B would be knotted, the A would be knotted, and I believe that's it. A naught C, B naught C, and it's going into an OR. So this would be our simplified expression of this Boolean expression, or this would be our simplified circuit of this Boolean expression. Okay, we're in number 5, and let's see, let's just go ahead and begin breaking this up. We would break it here, and here, and here, and here, and so here we have AB, and so we're going to say we will keep the A, B, and let's see, we'll keep the expression, and this will retain the naught, and that will be ANDed with, let's see, we will have C naught plus D naught plus E, and the E will not be knotted because we have the double inversion here. And so let's see, what can we do with this? We've got AB naught, and we do need to keep the parentheses here since this was a grouping. We need to keep that grouping together. And so we have AB ANDed with these, and so effectively that's multiplying, so we could simplify this to A naught B C naught for the first one, and then A naught B D naught plus A naught B E. And so this would simplify to, we would have 3 AND gates with 3 inputs, and they would feed into an OR gate such as this. And that is problem number 5. And this is, I don't have the detail here, but the simplified circuit would look kind of like this. And then the final circuit, number 6, we're just going to go in and begin breaking this. We'll break it here, 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 and here. And so the first part would be a knot, and we could keep the grouping, and we would, let's see, we're breaking here, so that would become, the operator would change, and here, let's see, we would retain the B naught, but the C would not be knotted, and since there's a double here, we would retain the same operator, so that would be BC, and then this would be ORed with, and again we're going to have D, in this case, we're going to retain the operator because of the double, and then the E, and then this would be knotted. So we have this knotted, and we retain the B knotted. All the other knottings are simplified out of the equation. Okay, in looking at this, we have A ANDed with B and C, so this could be simplified to A AND, or A or A naught, B naught, C, and that would be ORed with, in fact, we could just go say like this and remove those parentheses. A naught B naught C plus D or E naught. And that would be our simplified equation. And let's see, we would have a AND gate here with 3 inputs plus D and E, and then we would have, this would go into an OR gate, and then we'd have a separate D and an E that would feed, and then we would have our ORs. Let's see, if we label all these at A, B, C, the A would be knotted, the B would be knotted, and this would be D, and this would be E, and the E would be knotted, and that would be our simplified expression. Okay, these take some getting used to, and you're going to have to do some of them just to get the feel of them. After you do a few, they will become a lot easier, and throughout the remainder of this chapter we will be playing with these Boolean expressions. So just jump in and start playing with them, and they will eventually make sense to you.